So before we get started, have most of you people seen monarchs before? So you know what the butterflies look like. Have you seen many in your yard this year?
We've seen a lot of birds for walks.
Yeah, now that's a good place to see them. Yeah. So we're going to talk about why we're not seeing them. And you probably already have heard over the years that their population is in decline, but I'll talk about specifically what has happened in the past couple of years. So my name is Steve French. I work for Mass Audubon, and I do programs like this at local libraries, at senior centers. I take people for walks. So I'm generally out and about. Sometimes I'm inside like this, but most of the programs I run are outside. And one of the things that I like are different insects, but especially monarchs. And I think everybody can identify with a monarch. It's a beautiful butterfly, and we're going to talk about how it's connected with milkweed and how it depends on that, and also the fact that this is a migrating insect that migrates an enormous amount of miles. So what we're going to talk about is an overall view of butterflies and how monarchs fit into that. And we're going to specifically talk about the life cycle of a monarch. And it does pertain a lot to most of the butterflies, but specifically to the monarchs. Then we're going to talk about milkweeds and how there's this close relationship between the monarch and the milkweeds. And then we'll talk about this amazing migration that they do. And then finally, we'll talk about conservation. If we run out of time, there's a lot of that I can just cut out. So in Massachusetts, we have 5 different families of butterflies. And in those 5 families is a total of 105 species. And so the 5 families are the swallowtails. So if we look over here, we've got the tiger swallowtail. So this is a great example. We see a lot of them around here. Then we have the whites and the sulfurs. So this is a clouded sulfur. And a lot of you who have ever grown cabbage or a lot of different vegetables, you get these white butterflies that are the same shape and size as this. Those are cabbage whites, so those fall into that same category. Then there's the gossamer wings, and that's a lot of these smaller ones, and the American copper is a good example of that. And then there's the brushfoots. So that's highlighted because that's the family that the monarchs fall into. And rather than show monarch, I put a picture in here of a viceroy. Have most of you seen or understand what a viceroy is? So a viceroy is a much smaller look-alike to the monarch. And we'll talk about as we go along why it's doing that. It's doing that for a particular reason. And then the skippers is the last category, and this is a fiery skipper. So what role do these butterflies in general play? They're all pollinators. You know, they're like bees, like a lot of flies. They perform an important role in the habitats that we have, especially, you know, when we talk about pollinating flowers, pollinating vegetables, all different types of plants. They also, believe it or not, are eaten by birds. Okay, so they're providing food for other things like the birds and also for other insects and stuff and bats. And then they're also nutrient cyclers. So that's kind of a funky term. But what that really means is that they're providing the pollination to a lot of things to keep the growing cycles going. While they're in the caterpillar stage, they're eating things like leaves, and all of their excrement is going on the ground, and that's getting recycled back into the ground. They become adults. Once they're adults, eventually they die. They go back into the earth. So they're it becomes this circle almost. Now, monarchs in particular, we talked about how many species and stuff we have up here in Massachusetts. So if we look over here, if you guys know your maps, so this is what, South America? So monarchs are in part of South America, and this is what? North America, right. So they cover a good portion of North America. And there's a whole section up here to Alaska and up through Canada where they don't exist. And there's a good reason for that, because there's no milkweed there. And then there's some other populations over here in the South Pacific. But as you can see, they're not widespread. So we have the biggest concentration here in North America. And our monarchs in North America are the only ones that migrate. So all the other ones you see worldwide stay where they are. So I had a few examples over there for the kids, but I mean, the adults can look at them too. This is the life cycle of a monarch. So we'll start here with the egg on milkweed, a milkweed leaf. And normally where they would lay it, they try and lay it on the underside, but sometimes you can find them on the top. And it's just slightly bigger than the head of a pin. So it's really, really hard to see. So that's a blown up version of it. So you can see that it's got sort of like those ribs going down the side. And I'm going to talk just a couple minutes from now about how long it takes to go through this whole cycle. But eventually they become the caterpillars, which we have a couple of examples over there. And their whole mission during the larva or caterpillar stage is just to eat and grow. Then they eventually reach the point where they're ready to pupate and...
Climbed out of your container. I don't know if that's okay. It's on the side now.
Oh, is he?
Yeah.
Yeah, you know what he's trying to do? Where'd he go? Oh, there he is. So what he's trying to do, this is actually a great teachable moment. So that I had this closed last night because I actually didn't want him to do this. He is now ready to go into this next stage here. He's ready to go into this stage. And it's going to happen today. So I have to coax him to go back up. So what they do is you will generally not find the pupa on a milkweed plant. So the plant that they're feeding on, they usually leave that, and then they go 3-4 feet away and find another plant to pupate. So this is the stage that one is in, getting ready to go to this one. And then it will eventually turn into a butterfly. And once it comes out as a butterfly, it starts the cycle all over again. Its mission is to lay eggs. So let's talk about a little bit of how long it takes to do this. So this center one, the time is sort of an average. It'll show you a low and a high. So we'll take a look at the first one. So after the egg is laid, it remains an egg for anywhere from 3 to 5 days. So the low end, which is the fastest, is in the warmer climates. And if it's cooler, it's in a cooler climate, it's going to take 5 days. So on average, over there, the total time it's going to accumulate, we're going to say it's about 4 days. Then turns into a larva, and we've seen 2 different size ones there. And they're in that stage for about 10 to 14 days. So after about 16 days, they're complete on that cycle, and they head into the pupa stage. Once they do that, they're going to be in that for around 10 to 14 days. So when you accumulate that all up, take the average from egg laying to the day that it's ready to turn into an adult is approximately a month. So 28 to 30 days. And then as an adult, you look at that and you say, wait a minute, 1 to 9 months, that sounds crazy, right? So generally, the adults live for about a month. That's it. But if they only lived a month, how could they get from here down to central Mexico and then back up to the Gulf Coast? They couldn't, right? So there's something we're going to talk about called the super generation. And that's the last generation up here that is going to actually migrate. And they can actually live up to 9 months. So here's an example of the egg really blown up so you can see what it looks like. And you can see this person is showing you, there's their thumb and that little dot right there. That's the egg. That's tiny. Now we know about the egg, and in this case, this picture is showing where normally the adult likes to lay them, which is on the back side of the leaf because they're much more protected. So what we've got here is 5 different stages that the caterpillar is going to go through. So when it's first hatched, it's like tiny, tiny, tiny. And then after a few days, it gets to be a little bit bigger, and then a little bigger, and a little bigger. So there's a reason that we've got 5 different things up here. Each one of these, you would think that the caterpillar just keeps growing and growing, right? And it does, but its skin can only stretch so far. It's almost like a balloon. You can only blow it up so far before it pops, right? So what happens is to get from one of these stages to the next, they have to shed their skin so that they can get bigger. And what they call each one of those stages is an instar. So an instar is that period between when they molt. So this little guy way over there, the first instar, that one, I had one in there that was the first instar. He is now in this stage. He already molted, and he is now in the second instar. So that's what you're seeing over there. And you can see they change. We're going to do a few close-ups. So that's basically what they look like when they first hatch from the egg. They don't really look like what we're seeing over there, do they? They don't have the coloration. They don't have the antenna or tentacles in the front and the back. They have these little, almost look like horns. So once they're in this stage, you look, they're almost impossible to see. They're really, really hard. They almost look like a tiny little white worm. When they're born, they have to eat in order to grow, right? And they've got a few things that are stacked up against them that's going to make them have a hard time surviving to get to the next instar. So the first thing that they're going to run into is these things called trichomes, in that you can't see these unless you have a really good magnifying glass. That's on the underside of the leaves. And the caterpillar needs to get through those in order to get to the leaf itself, in order to eat the leaf. So that's its first challenge. The second challenge is, what happens when you break a leaf on a milkweed? Isn't this white milky stuff that comes out? Have you ever touched it with your fingers? It is sticky, right? It's like latex. And that's what they call latex. And that's the plant's mechanism to ward off insects and stuff that are trying to eat it. And it's also a way to repair itself. So if something gets chewed into its leaf, it completely seals it off. So these little guys, if they happen to hit too much of that latex, what it does is it just gums up their mouth and they die. So 60% right off the bat, after they hatch, die. So that's where this high mortality rate comes. They either starve or they get too much of that latex in their mouth, and it just gums it shut and they die. You know, now that I said 60%, you say, wow, that's a big number, right? Well, how many eggs do you think one of these monarch butterflies lays? And this is over, say, a 2-week or so period. Somewhere around 500 eggs. 500 eggs. And what they're trying to do is they're spreading them around. They don't go to one, they're not like it's one egg at a time. So they don't lay them all in the same plant. They go from one plant to another to another. So if there's a huge field, they'll visit every single one of those milkweed plants and leave one egg. So if you say right off the bat, 60% after they hatch are not going to make it. So out of those 500 eggs, how many do you think actually make it to adulthood?
200?
How much?
200?
You got the first number right, but not the 100.
20? 2?
2.
Oh my gosh.
2 out of 500 eggs. So that's why they lay so many eggs. They're facing an uphill battle just to get to adulthood. So as we move into the second instar, so remember what we said, the instar means that they have to shed their skin. So what happens is the skin cracks open and it peels and they kind of back out of it. And then sometimes they'll just eat the skin. It's just this very thin layer. Then they start growing again. And now, does that look like a monarch caterpillar? It does, yeah. See, it's got the black and the white. And you can see now that these antennae or little tentacles up here are now growing on both the front and the back. So we go another few days ahead and we get to the third instar and it's getting bigger. And now those tentacles are growing longer. The caterpillar is getting longer. Then we get to the fourth instar, and this is pretty close to what that one looks like, but that one is in its fifth instar. So you can see how much longer the front end tentacles are. And if we go to this one, look at how much different they are. They're really long and curved, and they're much longer in the back. So once they've reached this stage, this guy, after a few days of eating, is going to get ready, and he's going to know internally it's time. And he's going to go into a separate stage that pre-exists the whole pupa. So, and this is what he's trying to do right now. So he's still in the larval stage, and he's going into this J position. And if you can look up here, he's hanging from below a leaf or a branch or something. And like I said, usually it's not on the plant that they were eating. They usually get off of that and go to another one. And so in order to do this, what he does, he first climbs up here, finds a spot, and uses his mouth to secrete this like cement. And he leaves a little spot up there. And once he's satisfied that that's going to be good enough to hold him upside down, he turns around and he backs into it and attaches his back end to it. Yep.
Did they go to another milkweed just while they weren't eating from?
Sometimes they will go to another milkweed if that's all there is around them, but generally they're in with other plants, so it might be goldenrod or something, and that's where they'll go. So think about, they'll go like about 3 feet, up to about 3 feet away. So now he goes into this J stage, looks kind of like a J, right? And then he begins to pupate into that form that we saw over there. So he's doing this last molt. So this is what I was talking about. See how it's split? And the skin is kind of peeling up. You can see now he's pushed the skin, has peeled all the way up, and there it is there. And you can see this is the beginnings of the formation of the wings. And then he's finally pushed everything off. And you can still see a little bit of, look like the caterpillar. And then within a few days, it's going to look like this. So we had about 10 days or so from that point, he's going to be ready to emerge as a butterfly. And this is what it's going to look like. It's going to take a few days where it's going to start to darken up and you're going to be able to see some of the color of the wings. And when they're ready to start emerging, that's called eclosing. And so you can see it's beginning to push this flap open. And you can see the legs are starting to pop out. And it's all like folded up inside there, all those wings. And now it starts to pull itself out. And as it gets out, the wings are all like folded up. And then what it does is it kind of hangs on there for a few minutes, and it begins to pump fluid into its wings to make them completely open like that last picture. And when it's ready and its wings feel dry enough, then off it goes. Its first thought is it's going to go and try and find some flowers, going to get some food because it hasn't eaten and it's expended all this energy to do this pupation and metamorphosis. So it's out and it's on flowers, but it's also looking to figure out, oh, I've got to go find, if I'm a female, I got to find a male. If I'm a male, I got to find a female because I need to mate. And if you're the female, you have to start laying those 500 eggs. So we've got two pictures of monarchs here. What do you see that's different about them? Outside of the fact that this one looks a bit dustier and maybe had been around for a couple of days, it's got a little tattered wings. First clue, look at the veins here and here. Do you see sort of the difference there? One of them is a little bit, these are wider, and those are thinner. Now, if you look down on these bottom wings here, do you see a difference there? Yeah.
One of them has 2 dots on it, and one of them don't.
Yeah. So this is the male. So you nailed it. So that's the easiest way to tell. If you see them by themselves, it's really hard to tell that, you know, oh, that's a little bit wider veins in it than this one. But certainly this one does not have these 2 spots. And what those spots are, those are for pheromones. It's not used as much with monarchs, but some butterflies, that's the only way they can find each other. That is one of the things whenever you're dealing with monarchs, especially if what we're going to try and do next week is catch some and actually tag them. And one of the things we have to do is figure out, is it a male or a female? So, and you guys are going to help me do that. So now we know how these guys grow, and we know that they use milkweeds, but what's so special about milkweeds? So milkweeds, first of all, there are over 2,000 different species of milkweed when you look worldwide. But they all have some commonality. They all have that milky sap, which, you know, it's like latex, and it's there to perform that duty that I told you. So if the plant gets injured in any way, if, you know, you snap it, it will ooze that out and try to repair itself. They need cross-pollination. Some plants can pollinate themselves, right? But not all plants can do that. And this is one of those plants that can't. So you have to get the pollen from one flower, and you have to go to a completely different plant and bring that to actually germinate to actually start the process of germination in the other plant. These flowers here are very complex. They look simple, but they're very complex. In order for an insect of any kind, and we're talking about mostly pollinators, so that's why we see cross-pollination, they have to be able to stick a leg inside here, these little cups. That's where the pollen is. And they stick that in, and when they pull their foot out, the thing is stuck to them. Then they have to go find another milkweed plant, and they have to do it reverse. They have to stick their foot in, and it gets left behind. So that's way more complicated than we need it to get. But these plants have figured out they produce way more nectar than any other flower around here. So most of the pollinators, when these are in bloom, are over on these plants. They're used by more than 60 different types of arthropods. That's a pretty technical term, but they're laying eggs on them, they're eating them, they hang out on them, and they hunt other insects to come to them. So they're pretty instrumental plants. Now, a little bit about the chemistry and how that plays into monarch defenses. So, number one, monarchs will only lay their eggs on milkweed, right? And there's a reason. And one of the things is that these contain this thing. We already talked about the hairs, that's really more of a defense. These cardenolides, what those are, that's sort of a poison. And what they do is they damage any kind of a mammal's heart. Birds, if they eat the monarch caterpillars or the monarch adults, will get sick and regurgitate them. The reason why these are damaging those hearts is it's got this sodium, potassium, and then this ATPase is an enzyme. And those three things together work to regulate your heart. So if you have something that inhibits that, then you're going to have heart problems. So no human is going to consume these, first of all. But if you were to consume a lot of it, you would potentially die. So that's how it keeps things from eating it. But it also, if you think about these caterpillars, they're eating it and it's not bothering them, right? What they're doing is they're doing this thing called sequestering it. So they're taking all of those poisons and they're holding it and growing with it, and then they're going to pass it along as an adult to the adult form. So now they're protecting themselves, so if something eats them, they may be gone, but that whatever ate them is going to pay a price. And then as the adult emerges, it's got those same poisons in it. And so what happens is that those flashy colors they have, the oranges and the blacks, that's like a warning sign. Don't eat me or you're going to get sick. And so if we kind of go back to that picture I showed you of a viceroy doesn't use milkweed and is not poisonous, but it looks like a monarch. So if you're a bird, all you see is, oh, that looks like a monarch, I'm not going to eat it. Right? So here's a picture of a blue jay who didn't either read the memo or didn't get the notice that shouldn't eat these. So went out, caught one, he was very proud of himself and was pulling it apart. And then a few minutes later, it's like, oh, I'm sick. That was probably the last one that he caught. This picture is here just for a really important reason. It plays a very important role in the life of pollinators in general. So are you all familiar with this yellow flower? Yes. So this is goldenrod, exactly. So when do you normally see goldenrod blooming? Is it late summer. Right. So, and we're going to talk about when the monarchs actually show up. So you have flowers and bushes and everything that bloom in the spring, and then you have, daylilies and all kinds of other flowers that bloom in June. But then when you get to the latter part of July and into August and September, a lot of those flowering plants have already gone by, right? But what's coming out? The goldenrod. So the goldenrod plays a really, really important role for pollinators, but especially for monarchs, because monarchs are looking for as much nectar as they can get because they are going to be on this mission starting at the end of August in September to fly from here down to Mexico. So they need these. And so the fact that they're there in the fall is really important. So that plays into this whole migration thing. So here we are, all the way up here in Massachusetts, and this is where they're going to go for the winter, that little butterfly. So he's got to go 2,000 to 3,000 miles to get there. So Mexico City is right over here. So it's a little bit west of Mexico City. As you can well imagine, he's going to have to stop at an awful lot of goldenrod to have enough energy to get down there. So we talked about the fact that they generally live about a month, maybe 4, maybe 5 weeks as an adult. But there's this thing they call the super generation, and that's the last generation that is born up here that's going to make the trip down there. And that one has the ability to live up to 9 months. And the reason it has to do that is it has to make that trip all the way down here. It has to winter over, and then it's going to have to come back up along the Gulf Coast here through Texas and Louisiana, and it's going to have to lay eggs, and then it's going to die. So there's a bunch of sites that you can use. You can actually join them for free, and you can report when you see monarchs, or if you're into birds, it's the same thing in the bird migration. So what this is showing is reports, and these colors tell you by date. So they started up here, and you can see them moving down. So this is that super generation we're talking about. And this is their goal, to get down here.
We were just in New Hampshire. We saw a ton of goldenrod just along the highway.
Yeah.
A ton, yeah. North Conway. Yeah, everywhere.
So this map here, it's kind of simplistic, but it gives you an idea of the ones that are going, that we consider the eastern monarchs, are the ones that are in this big area here, right? And they have, they're east of the Rockies. The biggest population used to be out here, but they go up to this dotted line up here, and this dotted line is the furthest that the milkweed grows. And as the climate warms, obviously milkweed's going to be able to move up, so they'll be able to go further. But they all come together down here, and I'll show you some pictures of what they look like down when they get to the wintering grounds. There's two other populations in the US. There's one down here in Florida. This one doesn't really migrate. There are some that may move around the state, but they don't migrate down to Mexico. And then there's this one section here out on the west of the Rockies, and they come to California. And that one is on the verge of collapse right now. Starting the end of August, which could be now, I think that guy that's over there is probably part of the super generation.
The large one or the small one?
Yep. And the small one. And so that's what, so starting then, and they come down, and from November through March, they're going to hang out down here. And they're basically going to be in a place where it's really cold, but not cold enough to freeze them. And this is what they look like when they get down there. So this is in the Oyamel fir trees, and this is down in just a little bit west of Mexico City. They all clustered together because they can keep themselves warm because they want to be just above freezing. So if they do freeze, they'll just fall out of the trees. And if they can't get to some place where they can keep themselves above freezing, they'll die. But you can see how many there are.
So they don't eat during this stage?
No, they don't eat anything, but they will drink water. So if they get a warm enough day, these trees are near places where there's water that they can go and drink, and then they'll go back up into the cluster. And so it's important, let me just go back one. So it's important to keep this image in mind, because the way they determine how many monarch butterflies there are is by looking at the density in the number of acres that they cover. And then they take that, and this is from years and years of research, they're able to estimate how many there are. And that's what they look as they're flying in. I mean, it's like something out of Alfred Hitchcock, except good. So this is the one of the habitats that they go to. So I'm not Spanish, but it's the Monarch Sanctuary of Mariposa. This is now considered, it's in the high mountains, so they're above 6,000 feet where they're going to be wintering. And it's in the Milwaukee area of Mexico. And since 2008, it's been a protected area, and it's considered a World Heritage Site. And they work to really protect this area. Now, just keep in mind, it's no different, no matter what country you go to, you can protect an area, but wherever the border ends, anything can happen. So what's happening around that is population growth. They're cutting down timber in order to build houses, and it's commerce gone wild. So here they are hanging out during the winter. So they're down there from November to March. Let me just go back, because this is kind of an important thing. One of the reasons that they can live as long as they do, they can be this super generation, is because they are not in a state where they can breed. Okay, so their reproductive organs did not develop. So that saves them all that energy and all that stuff. But that has to happen sometime in order for them to come and lay eggs, right? So while they're down here in March, before they start their migration back up north, those reproductive organs develop. So that time period in between is called a diapause. And there's a lot of insects that do this. A really great example is ticks. You always notice that there's like this big upswing of ticks up through June, and you think, oh my God, this is the worst year ever. And then all of a sudden it goes down, and you say, oh, it's in August, and you're seeing ticks, but you're only seeing a few, and you're wondering what happened. Well, they go into the same thing. They go into a diapause, and then they pick up again in the fall. So it's no different. Insects have all kinds of capabilities that we don't. So what they do, they leave here in March, and they're going to head up, and they're going to be in this area of the Gulf, because this is as far as they're most likely going to make it. And they're going to find milkweed. That's the mission. Find milkweed and lay eggs. Develop your reproductive organs here. Come up, most likely along the way, mate. And when you get here, you got 300 to 500 eggs. You're going to find as much milkweed as you can, lay all your eggs, and you're going to die. And that's it. So you lived from here to here to here, and you died. So now we got to get some more generations, because these are going to be caterpillars then, and they're going to grow up here, and they're going to start to move north. And they're going to move north as the climate warms up in the spring and the milkweed becomes available. So you're going to have your second generation will be up in this area, most likely, along this line. And then the third generation will be, and the fourth generation will be up here. From March to April, they're sort of here in this area. And then from April to August. So we would not see them in April. We would probably see them the latter part of May, beginning of June, somewhere in there, depending upon what type of a spring we're having. Migration, same thing with birds, doesn't matter whatever it is that migrates, has to be able to figure out how to tell directions, right? So, I mean, there's nobody there that's giving them a map. They're the only generation that's going to make the trip down. The other generations going north don't know. They're just moving forward till they reach the end of their life, and then the next generation goes a little bit further until it's time to head back. So they got to figure out, how do I determine direction? How do I determine time? And how do I determine when it's time to leave, right? And they're all in the same boat. They got to figure this out on their own. And so if they have to go 2,000 to 3,000 miles, they got to cover 100 miles a day. That's a lot of traveling for a little butterfly. So they utilize things. So they use wind to help them, and they figure out stuff. But they need to know when to leave, because they're not going to make it if they wait too long and it gets too cold. So they have a little internal compass that helps them. They use a combination of their antennas in their eyes. So within the antenna, that has something in it that detects certain patterns, and it's able to tell approximately what time it is. And then they have compound eyes like most insects, so that they can see things differently than we do. And they use that to figure out, where the sun is in the sky. And so that helps them determine what direction they're going in. And so they use these two things to figure out time and direction. And this was all figured out by a bunch of research people at UMass and the University of Michigan. So now we're up to the points that you guys were bringing up when you first got here. So have you seen monarchs this year?
Not many.
Okay. I got 2 slides on this. So this first one, this International Union for Conservation of Nature put these monarchs on the red list back in 2022. So what that means is that they're on the brink of being endangered. I thought this was a really important thing to bring up. So each year what they do is down in that area that I told you in Mexico, and some of the other ones up in California, they're looking at the density of the wintering butterflies and how many acres they're taking up. So between the ones that went down in 2023, the fall, and wintered over, they saw a 59% decrease in the density and the acreage that they covered. That's the ones that are coming back. So it's a 59% decrease. That was just in 1 year. And since the 1990s, an overall average population decline is 80%. So you can see that's why you're not seeing them. In particular, more than half of the ones that should have wintered over and come back didn't. So that's why we're not seeing that many. So they are a candidate species for listing under the U.S. Endangered Species Act, which would give them a lot of protection. But that right now, it's just not happening. And politically, things just aren't working out. But eventually, we'll probably get this pushed through. And it may not save them at that point, but just to think that they should be doing that, it's the right thing to do. Not to belabor this thing, but these things here that you're seeing, like the 6.23, 7.81, these are hectacres, which is equivalent to about 2.5 acres. And this is giving you these bars going up, is how many acres, that density I was talking about, how many acres these butterflies take up in their wintering ground. So if you take 1966 to 1996 to 1997, look at how much that was. And this red line going across, they're saying that's the minimum that they should have. That's the minimum density to keep them from having their population listed as endangered. And so if you look at how many years they've been really low. And this was just this past winter, less than 1 hectare. So that's why you're not seeing them this year. And it's going to be really difficult to recover from that. Because if they can lay 500 eggs, but maybe 2 make it to adulthood, that's pretty hard odds. Somebody asked about the ones in California. So the ones in California, their overall population since the 1990s is down 95%. They are on the brink of collapse, and that's because of a lot of things, including the fire, everything that's happening out in California, all the construction, all of that has completely shrunk the area that they can winter over. So they are probably at some point just going to collapse, and they just won't, that winter over point won't be there anymore. We're going to go over, this is going to be a little bit more technical for the younger kids, but the threats that these guys are facing and why we're in this predicament now is, obviously we're losing habitat because we're building stuff, right? But look at these fields, That's all the food that you buy at the grocery store. And I'm not saying that it's right or wrong, but in order to grow that, there's a lot of widespread pesticide use, right? And pesticides may be used to kill a particular insect that is eating whatever this crop is, but it's indiscriminate, right? It's going to kill all the other things too. So the other thing that these monarchs in particular are fighting is this disease. This is a parasite, and let's see if I can get this. It's like Ophryocystics electroschera. It's a parasite that grows inside them. It's really insidious. So it infects them, and then what happens is they lay eggs, and the eggs have this parasite in them, so it keeps getting spread, right? And they pick it up from eating the milkweed, so it's on the milkweed. And it originated in Florida, and so they've got like this whole research study now going on to figure out, where is it, how widespread is it, how many monarchs are we losing? But also, monarchs are just like humans, they're susceptible to all different types of viruses. And climate change is wreaking havoc with birds and insects, and obviously the monarchs too, differing temperatures, stronger storms. It's, if you're trying to fly south and you come into a hurricane and you're a butterfly, your chances of surviving aren't too good. This is just, not to belabor the point, but, the summering areas that they go to, the milkweed is declining because we're using up the areas that they would normally grow. The Midwest used to be a huge area, the milkweed grew everywhere. But it's all under agricultural or being developed into living space for us. So all those places that the milkweed used to be is no longer there. And then there's different agricultural practices that are going on. I'll talk about one of the things that they do in a minute. But this area that you would think, this is protected, right? But everything around it is not protected. So the monarchs still got to get there. And as you cut trees out from around a protected area, you're exposing that area to, stronger winds, different weather patterns. And as far as pesticides go, this really plays an important role in what's happening to monarchs. We talked about this whole indiscriminate use. You want to kill one thing, you spray a multi-use pesticide, and you kill everything else along with it. And then a lot of times you don't know, if you go to the nursery, that the plants that you're buying have something on them already. They spray that so that they'll stay healthy, they won't have insects on them when they sell them to you. But then you plant them, and all of a sudden the butterflies come to it and they pick up the pesticide and they die from that. And then there are a lot of ones that are listed as organic, and you have to be really careful about understanding. Just because it's organic doesn't mean it's not going to indiscriminately kill things. You have to understand what it's going to do. And then there's these ones called neonicotinoids, and what those do is they treat the seeds of the crop that they're going to plant. And the crop grows and it has the poison in it, right? So the insects come, they try and eat the plant, they die. The flowers come out, they have stuff on it. So they call it a systemic kind of a pesticide. So you don't have to keep going and spraying, so it doesn't spread to humans, but it kills whatever it can. And then these are a few more things. There's this taconid fly that comes and lays its eggs on the caterpillars. And then when they hatch, they burrow inside and consume the caterpillar from the inside out. We already talked about the illnesses and the viruses. It just normal operation. Things go wrong, bad weather or whatever. So we talked about birds, and birds don't eat the adult monarchs because they know better. But guess what? Down in Mexico, here's a couple of different birds that have adapted, and they're able to isolate the poison and not digest that. So they don't get sick from it, so they come and they prey on the butterflies while they're wintering over. And then you get insects. Insects also come and attack the caterpillars. So this is why the caterpillars there's so few of them that actually make it. This is what can happen if you're wintering up in those fir trees down in Mexico. You're up above 6,000 feet. Think about Mount Washington, that's a little over 4,000 feet. And if you get a freak snowstorm, it can kill off thousands of these butterflies. So how can we help? Try and I've got information over there. The way station thing is a great one. So you basically want to have like something that you would consider a butterfly garden. So in this case, you would want to make sure that you have great nectar sources. If you want to host the monarchs, you're going to have some sort of milkweed. You want to have water of some sort. You could have bird baths. You could, whatever. I mean, everything, insects, birds, whatever, they all need water. And then shelter, some sort of bushes around to provide windbreaks, clean air, and, think about space in protecting areas, especially in your own towns. If someplace, the town wants to buy a particular field because it's no longer going to be farmed, and they have right of first refusal, if we could purchase that and save it as a meadow, it's going to help protect these insects and these butterflies. And this is a good example of what a butterfly garden might look like. A lot of flowering plants here. They have two different types of milkweed. They got common milkweed and the butterfly weed. Common sense, what makes a good butterfly garden? You want sun, lots of it. The shelter, so that, it's kind of keeping the wind from always blowing in from the northeast, so that you're protecting the butterflies. They have time to come and land on the plants and get the nectar they need. You want to have good soil, things that bloom in every season. So that gives you the ability to keep these butterflies around, because if all of your plants have already bloomed by the time you reach the beginning of July, then the butterflies aren't going to come to your yard. And here's just a few different pictures of the monarchs. And you can see they love nectar-producing flowers. It doesn't matter really what they are. I mean, if you can think in terms, if you're going to build a butterfly garden, think in terms of native plants, because they're adapted to, our climate and our zone up here. They're going to do much better. And then the milkweed, I have a handout over there. If you're interested, it talks about more of the milkweeds, but these are the ones that the kind of host the most of the monarchs. So this is butterfly weed. This is a really nice one if you want to plant something that's not going to take over your whole garden. They have this sort of really bright orange colors. This middle one is our common milkweed. And the one over here is kind of nice, but it requires a little bit more moister ground. This one is swamp milkweed. And I'm just going to gloss over some of these. There's all kinds of resources out there. These are monitoring programs to actually count, different things like when the monarchs arrive, if you can see them laying eggs, whether or not they're pupated. All these do different things, and they're for different regions. Next week, we're going to talk a bit about this Monarch Watch and why that's important. But these are all community science things. These are not things that you have to be a scientist to do. You can do it. You can do it as a group. You can include classroom kids and stuff doing it. And, some of the the reasons we want to do it is to understand what's happening to these insects. You know, why are the populations going down? Are they going up in one area and down in another? You know, scientists then take that data, they collect it, and then they start to figure those things out. This is a flagship species. So, you know, do people know what a flagship species is? Absolutely. Hit the nail on the head. It's something that sort of represents it. You can identify with something that everybody loves, you know? And so it's really hard not to love a monarch. And they have ones, the larvae, you can monitor those. We've used these throughout the presentation, so just go to Journey North, and there's a bunch of things you can do there as far as these maps, and you can also just set up an ID to go into it. Doesn't cost anything, and you can monitor when you see monarchs or whatever you want to. You know, they do hummingbirds and stuff like that too. And then this is what we're going to talk about next week, so I'm not going to spend a whole lot of time on it, but these two people here, Fred and Nora Urquhart, started this whole thing called Monarch Watch because they were curious as to, you know, what happens to the monarchs in the winter. So they started this whole tagging program so they could figure out, you know, do they leave? Do they go? And this is how we learned about the whole migration. And that's what we're going to talk about next week. It's a great thing. Anybody can do it. You can sign up and do it. And it's a great project for like kids at school, you know, good September project. And we talked about this OE parasite. There's a whole thing here that monitors that, and you can log data on that. You know, what can you do about it? I think we talked about most of these things. You know, what if you're passionate about this? Talk to other people. You know, encourage them to, you know, care about the monarchs. You know, don't just indiscriminately pull up milkweed, but you know, if you have some, I think it's a good thing. Make sure you've got nectar plants for the adults. But, you know, this is probably the most important thing, is just get involved in some way or another. And these are just a few of the resources if you wanted. You love butterflies. The Mass Butterfly Club is amazing. They hold walks all the time. In our Mass Audubon, we have this thing called the Butterfly Atlas. It has all kinds of information on a lot of the butterflies around here. So there's plenty of resources out there. So that's the end of my presentation. And I hope you learned a little bit about, maybe you knew some of it, and maybe there isn't stuff that you knew, but you know, I think it's really important because all of these things, to me, the birds and the butterflies, the insects, we are seeing populations just diminish before our eyes, you know, and we're just not seeing the action taken that needs to happen in order to protect them. And we don't want to leave this to the next generation and then they're left with, you know, where are all the birds? What happened to the butterflies?